to my channel again, Insight with Tola. And today we have with us a very important personality in person of Engineer FUTA Oke, Kayode. He's the Dean, School of Engineering. Sir, can you please introduce yourself and give us a summary of your career?
Thank you very much, my fellow Engineer Tola. My name is Professor FUTA Kayode Oke, a professor of mechanical engineering and the Dean, Pioneer Dean, School of Infrastructure, Mineral and Manufacturing Engineering. Formerly the Dean, School of Engineering and Engineering Technology, Akure. I know some people might be looking at it that
I'm wondering.
so be looking at it that I've been Dean, School of Engineering and Engineering and Engineering Technology from year 2021 to year 2024. At that time, based on the scope and the way engineering is developing in FUTA, they look at it that we are becoming extremely wide, and it's always very good for us to professionalize our area. So those engineering field that is in the area of electrical system, electrical area, we group them together. And those that are in the area of manufacturing and infrastructure, we group them together. Based on that, the former School of Engineering and Engineering Technology was split into two, in which I happens to be the Dean of the old engineering before, and that's why I said I'm the former Dean of School of Engineering and Engineering Technology, which later split to School of Engineering, School of Electrical System Engineering, and School of Infrastructure, Mineral and Manufacturing Engineering. The School of Electrical System Engineering is being headed by another professor, Professor Melody. And that's what makes me now to be the pioneer, School of Infrastructure, Mineral and Manufacturing Engineering from year 2024 to the date.
Congratulations, sir.
And based on, I got my B engine from former Ondo State University, now it's State University. Got my master's and PhD here in FUTA. Now I became professor of mechanical engineering in FUTA. Thank you very much.
Then what inspired you to choose mechanical engineering? There be something that triggered that?
Definitely, I so much like what they call something called mechanism. Something that works, that when that two things relate together, it brings certain work. At initial stage, human being actually behaves like machine. And I want to tell you that most of this mechanism, the basic principle of how human being really work. We eat,
Yes.
that should be taking fuel, and the fuel now will be worked on this mechanism, and exhaust. At the end of the day, you get exhaust out of it, and in the process of that, produce energy and produce work. The same thing applicable to mechanism machine that fill in with fuel. It actually based on the mechanism and some other things, you get the exhaust out. So initially, I really have intended to do medicine based on the way things really work. And when I discovered that the mechanism of human being cannot, so I decided to go mechanic, because mechanism, things working together, inlet, process, and outlet. That is my major reason to actually going for mechanic.
Please, can you tell us the memorable project or achievement that shaped your career? I know you have more than one, but just tell us one that really changed that career.
I've worked on on many projects. But there are some projects that I work on. I work on development of solar panel. Development of solar panel. You know, we normally import solar panels.
Yes.
And we believe that we are arrived by importing solar panel. But I look at it critically that yet we are still depending on imported goods. But we look at it that there are some kind of materials that we have here. We have lithium, we have all the materials necessary for production of these solar panels. So I actually use my students with the knowledge we have to actually get the solar cell. There's a solar cell produced, and combination of this solar cell make up what they call solar panel. So, and which we develop, and today we discovered that the solar cell is working, and which we are working on now in a way of combining series of these solar cells to make solar panel, which is making me to have certain kind of confidence that very soon we have a solar panel produced in Nigeria. And I want to actually draw your attention to certain thing. That this solar panel, you know, lithium, but we discovered that most of these elements, of lithium elements, it can be seen in Moringa leaf. I work with people in chemistry, and we did the analysis that the only problem, the only stumbling block in getting this lithium is extraction process in Nigeria. And we look at it that there are certain kind of indigenous things that from that particular thing we can get that lithium out. And I want to certainly talk to that the lithium, the solar cell we produce was produced using Moringa leaf.
That's interesting. Viewers at home, you have Moringa leaves, that's money. Thank you for that. Please, can you give us a significant challenge that you have faced in your career? Very significant one.
Well, definitely, you know, we agree with me as an engineer that for us to get this done, engineering is very expensive. Even a lot of ideas we have, but money to finance the projects have been the major challenge that we're facing. So before we get this one done, this solar cell issue, it's as a result of the sponsor from TETFUND. If it's not for TETFUND's assistance, we wouldn't have been able to actually avoid that, which actually almost cost us almost 2 million. So major challenge that most engineering things normally face is money. You know, and whenever you want to get something done, you cannot do it first and get it right.
You have to.
You keep improving on it, and which makes things to. So these are the major challenge. This is the major challenge. Finance is the major challenge that we do have, that are restricting us from making our research outputs available in the market.
So how do you approach problem solving in complex situations? I believe that for you to become a professor, I know it's very small challenge. So how have you been able to surmount those problems?
You know, most of the time, I actually have one idea. I have certain things at the back of my mind, which I always inculcate in the mind of my students. There's nothing impossible for engineers. There's nothing, if you believe in your mind, that is the major thing.
Just like
if you have it at the back of your mind, that there's nothing impossible for you as an engineer to do, because you are trained to face challenges. You are trained to face challenges. You are not trained to be doing a routine job. So immediately you put it at the back of your mind. That's what I put at the back of my mind, that as an engineer, there's nothing that is impossible. I'm not God, but I do tell my.
Even God said it.
I'm not God. I do tell most of my students jokingly that when God is creating heaven and earth, that engineer practically open one eyes to see most of the things God is doing. And as a result of that, when an engineer is being trained, we are trained that we should have it at the back of our mind that there's nothing impossible. And based on that, you know, as an engineer, you get to work today, you get to a place of work. You don't know the type of projects, the type of machine parts. You just don't know the type of machine parts that we need to, what is it called? All the things that you'll be given by your boss to produce. So immediately you are given, it's a challenge. And you know that immediately quickly think and use all the academic works, all the experience, you put it together to actually get what has not been existing and bring it to an existence. So, and that's the reason why I said what the principle I've been using is putting it at the back of my mind that I've been trained to solve anything, to face challenges. Thank you very much.
So what key skills or attributes is necessary for one to succeed as a mechanical engineer from the experience?
And the last question is almost going to answer the second one. As an engineer, as a mechanical engineer, immediately you have that one at the back of your mind. And two, you don't procrastinate.
Procrastination. Viewers at home, I hope you are hearing Professor Oke. Do not procrastinate.
You don't procrastinate. You know this thing is possible. You strike, you act on it immediately. Because this idea comes. You know, some people, some machines will tell you that the inspiration to come even when they are sleeping, even when they are eating. So as an engineer, you think all the time. And when that thing comes immediately, you act on it immediately. Or else, the idea you might not actually be able to grab it again. It's just like an inspiration, and that's why anytime you believe that there's nothing impossible. Two, you don't procrastinate. Anything you want to do, you do it immediately. And I know very well, definitely you get things done.
So, can you share with us an experience of a failure that you turned into success in your course of career?
It is
look like a failure, although we are bound to face challenges as engineers, but in a way you now turn it to success.
Yes. You know, there's certain kind of, I was doing a project sometimes, and that project is on automobile. I was using on that again. So I had discovered that this Honda thing, most of the time you see the hand, you just be.
Okay. I normally see that on the road.
You just
shaft to just
come up.
Come on.
What is likely to be the problem? This failure that I do face, based on this, why can't I work on it and see what will have been the solution to this thing? Which makes me to go to what they call interchangeability of machine parts. Interchangeability of machine parts.
You can use another part
to another, which happens to be the major problem of that under there. Whenever you get to mechanic will tell you, should be this under so under. This part is the same thing. It's almost you can use it. Not knowing that those people that have done it with little tolerance, with little dimension difference. That's what is making those parts to give away. So I can now advise, based on the failure on that particular thing, to tell people that if it's not part of under 2022, don't use it. Even if you are advised by those mechanics that they are almost the same thing, it will work. It will work, but it will give away.
At an unexpected time.
At an unexpected time. Because it's as a result of series of failure of using all those kind of things that makes me to actually go into that kind of research. And going to that research, I'm able to establish major cause. And I do still up to now, I normally see all those things happening. that is this a good opportunity to advise, most especially those people that are using Honda. That their mechanic normally give them advice. You can use this one to fit this one because they are almost under part and it can work. It will work, but the stress and because of the dimension difference and the tolerance, the difference. You know, the distance can be just micro millimeter difference. And if you make it so, but the stress that one will cause on either ball joints or something or something might be much. The ball joints will just give away, but it will be working. It will solve the purpose for a while. So it's failure during that makes me to go into that research. That at the end of the day, and this thing is published. It's published in a very wide.
That's a good one. So viewers at home. When you have your car Honda, be careful. Don't allow mechanics to tell you to use, like I just said now, there's a paper written on that, practical paper on that interchangeability. You should be careful. Thank you for that, Prof. Then what advice will you give young engineers that are starting their career? Either intending or already in the field.
Engineering field is an area that needs to have patience. Don't be too much in haste to make money. And it's something that if you have patience and you take your time to learn it very well, you surely will be excelled. And you know, like what I normally tell people, don't run after money, but run after value. Value. Because people will end up paying for your value. People will end up paying for your value. Immediately they know your value in that area. And you can only get that value if you have patience to learn that particular thing at appropriate time. But if you lack patience, you will run after money. Then you will not get enough knowledge to get value.
Eventually you get the money.
So and definitely the money, you will not get the money. And you believe that engineering field, there's nothing there. But as far as I'm concerned, I want to let people know that in the engineering area, that there's money. If you try as much as possible to add value to your life.
So value brings money.
Value brings money.
And because a lot of people are saying engineers are not rich, they're not that.
Value brings money.
They should go back to the drawing board now and learn.
Yeah, they should take for example. FUTA junction, the menu.
Yes. That man that has a turning machine.
If you get there, if you're a mechanical engineer, if you get there, it's because I learned that the first born of that happens to be a mechanical engineer. And he's working there. He had value to himself. He's doing the job. People are rushing there to actually do one thing or the other there.
Yes.
And definitely, do you think that person will not have money?
Money will definitely flow in.
If not money, if you sit down there, money will definitely flow in.
Yes.
Because one way or the other, he has succeeded in adding value to himself. So money will follow him. So I want to encourage them that there's money in engineering, provided that person has patience and take time to learn what he's supposed to know, and thereby add value to himself. Money will surely follow him.
Thank you, sir. Advice of value. So, viewers at home, you have heard from Professor Oke that you should first of all add value to yourself, and the value will bring money. Then, Prof, is there any misconception about your field, mechanical engineering, that you want to kind of clear? Because definitely there are misconceptions in different fields.
Thank you very much. You know, most of the time, people, whenever you actually mention it to anybody that you are a mechanical engineer, what they will first think about is that you are a mechanic. You are a motor mechanic.
It's true.
I said you are a motor mechanic.
A mechanic, John.
Maybe you are a motor mechanic. I said, what's happening? You are a mechanical engineer. Your vehicle is having
mechanical problems,
and you are trying to take it to a mechanic shop. So you need to actually find a way of explaining it to them that mechanical engineering what they are talking about is an aspect of mechanical engineering, which is we can refer it to as automobile engineering. But mechanical engineering is extremely wide, which deals with building services.
Yes.
With anybody dealing with AC, dealing with
Plumbing,
dealing with pumps, and some other things. It involves manufacturing, production, and industrial. Production of machine parts. That in case you want to produce machine, your area of producing that machine parts,
yes,
assembling it, and fabricating it is part of mechanical engineering. So it's extremely wide that people believe that with their own mentality that immediately you call yourself mechanical engineer, you are a mechanic. And definitely there's another misconception that people are having, that is that they don't know that there's an hierarchy in engineering. We are family,
yes,
and we work together. And there's what we call pyramid
of
engineering field. That we have the technicians,
yes,
we have the technologists, we have the engineer,
yes,
and all the categories have their own area of specialization. So whenever I'm just telling you another misconception. That you are an engineer, why can't you go there and keep removing it? Then you now need to explain it to them again that in this field there is what we call engineering pyramid,
yes,
which we have the technicians, and these technicians are those people that you refer to as mechanics.
That's the lower level. And
these are the technicians that are really involved in dismantling, removing, and some other things. And the next stage to them is we call them technologists. And the next stage is the engineer. The technologist is an intermediary between the technician and engineer. Engineer knows everything. If an engine should cough, engineer knows exactly what is the problem. And he'll be able to explain to the technologist that based on this kind of sign and this thing, go to so area and these things and that. And he knows how to explain it to the technician. He has the language to explain to the technician that, okay, the engineer said, based on, and immediately they go straight to that particular place. That's what is going to happen. What is the advantage of that? It will reduce the downtime, production downtime. If you take your vehicle to a mechanic, a mechanic will be doing trial and error. They can spoil what has not spoiled. It will waste your time, it will waste your money. But if you take it to a professional engineer's workshop, immediately you get it there, immediately you start, you tell them that go to so place. They will go there, they will change it or use necessary machines to actually test it and use necessary tools, and thereby it will reduce the cost and will reduce the downtime as a result of that. So, and that's why some people, when they are just talking, then these are the misconceptions about mechanical engineer, that they look at it that anybody that's a mechanical engineer is a mechanic. At the same time, why can't you do number two? Why can't you do your vehicle yourself? So except we explain to them, majority of people did not know this.
Because even my prof, thanks for that comment, because I found that a lot of people, they sell their time. As a mechanical engineer, you have so many things you are thinking of. So are you the one that will now sit down and start dismantling your vehicle, or give it to somebody who can do it and you pay him stipends? Thanks for that. Then how can one stay relevant in this profession as a mechanical engineer? How can one stay relevant and be, you have to stay relevant in your profession.
You know, one thing links to one other. One thing links to another. You know, someone cannot just be a professor of mechanical engineering if he did not put much effort to add value.
Yes, yes.
Somebody cannot be known as a professional mechanical engineer if one way or the other he has not committed himself to ensuring that one thing, they know him for that.
That's focus.
You know, I mentioned, thank you, focus. I mentioned one example there. I never know that you still ask this question. The menu.
Okay.
the automobile person, if you want
turning,
to
turning machine,
and some other things. Whenever you have said, don't you know the menu? Please go there. You will get it sorted out. It will look like new. They will do your vehicle, your crankshaft, and they do your crankshaft. I'm sorry, it's not that I'm advertising for that. You don't know them.
No.
Are you get what I'm saying? But what I'm trying to say is that because of the question you asked,
Yes.
because he has committed himself, his focus is deliberately focused on that area. So if you want to be relevant, be focused. A certain area of mechanical engineering.
Pick a niche.
You know, I told you that mechanical engineering is very wide. We have building services, we have manufacturing, we have automobile, we have autotronics, we have just like that. You know, immediately you know that it's getting to a point of being relevant. You pick one.
And you stay there.
If it's building services, you really want to get yourself committed there. I have somebody, he read mechanical engineer, but he's an expert in welding process. And he's using it now. He's extremely rich. He's a contractor to nearly all buildings in Nigeria.
I hope people are not calling him welder.
Are you get what I'm saying? And so you know what I'm saying? All their pipes, all their pipelines, all their storage, all their these things like that. You know, metallurgy has to join it to actually make sure corrosions, effect, and some other things. And you know that this metallurgy and material is a subset of mechanical. So he actually look at it that in this area, let me focus on welding process. And he actually go and learn a lot of techniques that can make that thing super. And people recognize it and they keep patronizing him. And now it's extremely value. So I mentioned two now is being focused, being committed, and ensuring that what you pick, you really work on it for people to know.
You're a master of it.
Thank you very much.
So thanks for that, Prof. On the lighter mood now, what do you do outside engineering or outside lecturing? When you're not lecturing, what do you do? In form of relaxation? What do you do?
One way, I like sports.
What kind of sports?
You know, this time around, I like football and table tennis. But this time around, because of age, I hardly play football again. I try as much as possible to manage myself to actually play table tennis. Yes. So to get myself fit.
If you are told, if you are asked now, the question that you are to meet somebody who has existed or who is existing, a senior person and engineer, who would that person be and why? That you would like to meet?
That is existing.
Or dead.
Is existing. The person is Professor Aderoba. The person is Aderoba. He actually changed my orientation towards this mechanical engineering. Now when you are coming as a young engineer, you have a lot of things attractive. But all these things I'm saying, he was a person that told me that, okay, I know you are very brilliant, but for you to, you come for lecturing, but what you first do, I was attached to him as a graduate assistant. You said you start from workshop. I was thrown to workshop.
Not to the class.
Not to the class. I was thrown to workshop to be taking workshop practice, in which all this late machine that we are introduced to in the university, all those things that I've done on on welding, all those things that I've done, all this when I was serving. So then, really, I now lay my hand on these things. So that makes me to leave being a theoretical mechanical engineer to a practical one, which made me to be extremely happy. He told me, he said the reason why, so that you will not be frustrated one time, any time that you don't expect. He said some people will believe that you know theory, you know practical. You can tell them do this, do this, do this, do this, do this. But when they discover that you don't know how to handle it, they will frustrate you one day. He said try. So this time around, I can handle lathe machine, I can handle welding machine, I can handle all these machines. So no technician, if I should direct you to do it, and if you are saying that I do it myself, immediately discover that you are doing it. Tomorrow he will do it. Immediately you direct him, he knows that he cannot make. So definitely I see this kind of man to be a practical, real. It's not theoretical professor of mechanical. It's a practical one, which actually helped me that, like this man, definitely I would like to be like him. And definitely, you know, anybody that knows him, he knows Ondo.
I know him.
If you know him, you get to his company. You know, really, this man is a practical engineer, mechanical engineer. It's not teaching theory. After teaching it, he actually established all those things that for us to see. So I'm still trying. I'm not yet there. Because what I discovered that he has done, I'm still struggling to meet up that. You know, if you get to his company, he has lathe machine, drilling machine, series textile machine, you know, industry. So it's not that I'm a professor that will lecture in the class, that there's nothing to show for it. So, and that's why he's still alive. And definitely anytime, any day, he will always be my mentor.
Yes. Aderoba, wherever if you're listening to us right now, we appreciate you. Professor Oke, we appreciate you. I was once your student, masters.
It was my PhD. I was my PhD supervisor.
Thanks.
Masters, PhD.
That's good. I think it was not the pioneer mechanical professor here in FUTA.
Yes.
That's good. Then, what fun facts about what is definitely what is the fun facts about you that a lot of people may not know, but you know, and something about fun about it. You know, the way people perceive us from outside, they might look at you as this person is this, but you might not be like that, and it is fun.
Well, anybody from far, which I've had, people see me to be a top person.
That's their perception.
And you know, and people see me, you know, when you look so quiet, and most of the time, people will not be able to predict specifically what the type of person you are. And most of the time, when they discover that anytime you talk, you are a very factual person. I'm a very factual person. You know, a quiet person, you are very factual. And when you are just talking, I said, Professor, my fellow, what you are saying is not correct. And I don't think I will agree with that because of this. You know, somebody that is watching me for the first time, you say, this man might be very tough. But definitely when that person moves closer to me, he will discover that I'm a person that cannot hide my feelings. I'm a person that, even if you are close to me, I will tell you what I think I should let you know. But immediately you will not even want to leave my vicinity. Because you now be, some people say, oh God, you think that
you are like this.
But it's only those people that get closer to you that knows you are not like that. So.
Thank you, Prof. Before we end this program, I want to recap a question. You mentioned something earlier which I was not aware of. I'm just getting to be aware of now. And then which our viewers at home might want to know. Your new school, you're now the dean of explain and tell us what courses are there for students who want to study engineering so that they can apply it to FUTA.
So thank you very much. Definitely, let me use this opportunity to thank our VC for being magnanimous enough for granting the new school. We discovered that before, School of Engineering and Engineering Technology is made up of 12 departments. And these 12 departments, a dean want to work on all the departments, getting their results, getting all those things and something or something, which somehow a little bit cumbersome. And for us to be able to address all the challenges of all these departments, I think there's quite a need for us to look at it critically so that we'll be able to effectively discharge our duties to staff and to students and good management of the school. So we look at it, we think, and we believe that let's actually we are right enough for management sake. So it's splitted to two. And not just being splitted anyhow.
There must be a
but
reason
there must be a reason. After that, we have departments that are electrically related. Extremely electrically related. We have electronics, we have computer engineering, we have information communication engineering, ICE, we have mechatronics, and we have biomedical engineering.
Okay.
So these courses now, we look at it that despite the fact that some of these courses are mechanically related, like mechatronics and biomedical, but because of the electronics part, that if there will be a mechanism for mechatronics, there will be a mechanism for biomedical, but electronics part, we look at it, they can fall either in A or B, but we prefer to take them to electrically related area, and that we call it electrical system engineering. School of Electrical System Engineering, SESE. School of Electrical System Engineering. School of Electrical System Engineering.
And that is
SE, that is SESE.
So viewers
the other school is made up of 7 departments.
Okay.
While that one is made up of 5 departments, okay. Which I mentioned: electrical, computer engineering, information communication engineering, mechatronics, and biomedical. Okay, so the other 7 is made up of mechanical, metallurgy, mining, civil, chemical engineering, agricultural engineering, and industrial and production engineering.
Okay, that's
7. And that's why we have School of Infrastructure. That infrastructure covers civil and agriculture partially. Minerals.
I now get it.
Minerals covered metallurgy and material engineering and mining.
Okay.
Manufacturing covers industrial and production engineering and mechanical engineering.
That's good.
So these minerals, we're actually looking at it that it's covering 3 departments: chemical, mining, metallurgy, and material. Infrastructure is covering about 2: civil and agricultural engineering. Manufacturing is covering 2, which is industrial and production engineering, and that's why we have School of Infrastructure,
SI,
mineral,
M,
and manufacturing engineering. That is SIME.
SIMME.
In which I'm the pioneer now.
That's great.
So definitely anybody that have.
You're a man of many caps.
So before I was in charge of 12 departments.
Now
in charge of 7 departments.
That's good. That's good. And please, may I know who is the current VC now?
The current VC is Professor Timidayo Adenike Oladiji. So, which they have been so very good to the school. And, most of the time, I always tell people, you are here, you are representing VC here in the school. The dean is representing VC in the school. So the reason why I'm thanking him that and I'm thanking her is that anytime I have challenges beyond my capacity, I will rush to her. Madam,
This is
this is the problem.
situation.
This is the situation. And I do make it known to her.
Yeah.
You put me here, and I'm representing you here.
Yeah.
This challenge is more than what I can carry.
So,
And by the grace of God,
she
she normally try
so
what
VC,
she can do to sort it out.
Madam VC, Professor Mr. Adenike, we are grateful for what you have done for FUTA and School of Engineering. I was once a student here too. It was only that same one school that we have. Now we have two. Thank you, ma'am. The gifts might look small and infinitesimal, but it tells us of where we are coming from and how we started this engineering career. And the gift is this pencil, this clear pencil. My Prof, sir.
Thank you very much.
This is a token of appreciation.
Thank you very much.
Thank you for your time. And we know that that's where we all started from. You will sketch, you will clean, you will sketch, you will clean. So that's what we are presenting that cross. Once again, we are very grateful for your time, sir.
Thank you very much. Highly, and I feel the honor for coming. And I really want to thank you for this precious pencil.
Thank you, sir.
Some people might look at it to very special and something, but it's what you can say giving somebody tools that initially he must have, and he will be using throughout his career, except it's no more art. So I'm still drawing, and I still continue to be drawing till. So thank you very much.
Thank you very much. So viewers at home, thanks for listening. Goodbye.
Are you